Hi everyone. So today we're going to talk about how we can crunch in and ingest data from one of the sources, in this case from the Open Weather API, and read that data and visualize it. A little simple visualization using Google Looker Studio. So I'll give you a brief overview of the architecture. It's pretty simple. So here we have the API from where we're extracting or reading the data from. So this is the Open Weather API. So we write a short Python script and we get the data, ingest it, and we apply a bit of transformation using the Python native Python script as well as pandas. And on top of that, we apply a second level of transformation as well using dbt. And to persist or load the data, we use a bunch of solutions here. First one, we use the Google Cloud Storage, and we have local Postgres instance as well as the BigQuery. So finally, in order to visualize, give it a visualized view, we use the Looker Studio, which we just saw over here. So in this case, we've used a prefect to orchestrate the entire deployment. So if I just submit a command over here, uh, let's just give this command. So this should start the deployment process. So it says that it has created a flow run for the deployment ETL main flow slash AQI stacks. That's just the name that we've given for this deployment. We just head over to the prefect local instance that we've held running. So this has started the flow. So this is the main flow. And if we go inside, yes, now we can see that all of these flows and subflows and tasks are running sequentially. So as you can see, and we can also see what is going on inside each and every flow. So here we can see the data is being stored to the local Postgres instance. And if we were to look in the code itself, so this is the code, and here uh, we're just extracting the data from this code block, and which will actually run this package or method. And here, if you see here, this add flow decorator is actually a part of the Python package that we're using. So that is how Prefect knows that this is actually a flow that is initiated, right? All right, so let's see. It's going on. It's going on. So it's running. So finally, as you can see, we're in this phase where it's loading all these data in the BigQuery. So like it's successful now, and it's now triggering the dbt flow, which we mentioned here, right? Now it's running the dbt transformations. So dbt transformations are very much useful when we need to, apply transformations during the analytical phase of the data, especially like we saw during this. This is the data analysts, they and the data engineers, they can have a common platform, which in this case is dbt, where they can apply transformations, and these are all simple SQL scripts. So now our flow is complete. It's completed. It's passing. So we'll just go ahead and see if the data has been correctly uploaded, right? So here we see the date is Jan 23rd. So today is Jan 26th. So let's refresh the data. So it's fetching the latest data from BigQuery. So we can see here, so Jan 26th, 3:45. And the granularity of the data freshness actually is on an hourly basis. So this is perfectly fine. And we see in this visualization that the currently, depending on the latest, based on the latest AQI facts, we see that Beijing, Islamabad, the air quality is pretty poor there. Kathmandu has a moderate AQI level, and London, Moscow, they're the ones with the fairest levels. So yeah, we got some very simple uh, things here. And if I were to show you what DBT actually provides us with. So, all right, so this is the view that DBT provides, and in this case, okay, so if we were to see over here, so if you see here, it provides us with the option to visualize our documentation as well, which we have defined in the creation of the models. So DBT primarily is used for data modeling and especially in the ELT phase of the data fetching and applying data modeling logic to it. And it also has the documentation for all of the columns, column types. And we also have a nice dependency here, like it's referenced by this model. And if we were to get a bird's eye view of the models, we can see the lineage graph like so. So here we see that the year-wise AQI stat, this model is, well, it's dependent on all city AQI with description. And this in turn is dependent on the staging dot all city AQI. If I can briefly show you how it is defined in the code, it's pretty simple actually. Uh, Under the custom models folder here, so these are all under the staging folder. These are all the models that we have defined. So year-wise AQI stat. So yeah, so this is nothing but just simple SQL, right? The syntax is almost similar. However, everything that is inside these two double braces, they are Jinja expressions, and it's how the config materialized view. It creates a view in the destination data persistent, your destination where you want to persist this data or save this model to. And in this case, it's a reference to this macro. Now, macros are just like functions, but in the world of DBT, they are called macros. And if we were to look in this, so it's just a case statement, right? It looks like a function. So inside that function, it's actually a case statement, SQL case statement. So it accepts a parameter called AQI level. Based on that AQI level, the value of the AQI level, it returns the description, right? Whether it's good or fair, moderate, poor, very poor. So we can use this macro in any of such subsequent models that we create in the future. And if we were to dive into uh, the sources, so we can just find the sources YAML. It's also part of the DBT world. And if you see here the sources as we have defined, the name is staging. So under staging, and this is our BigQuery data set. And here we have defined there's a table called all city AQI. It also has description, which we saw in the web DBT solution earlier. So DBT also supports primary checks such as, checking for accepted values. So these columns should all only have values within this list items. We also have normal checks such as not nulls, right? So it's a good way to incorporate this in our CI/CD pipelines as well. And as part of the DBT philosophy, it actually pushes the developers, or rather the data engineers or analysts, anybody who's playing with DBT, to massage their data, to follow best practices. And it also natively supports CI/CD as well. So yes, yeah, finally, I'd like to show you how it's all saved. So here we see DBT core models. Under this data set, we have a bunch of items. So like I showed earlier, right? So this all city AQI, latest AQI, all these things, they are generated. These are all models, DBT models. And when we ran that deployment command in the DBT phase, these all got created, and these are views. Since we had defined the materialized configuration as view, so these are only views. And so these are the data that I used to create this dashboard. So that's it from my end. Thank you all.